there's demand is increasing and supply is increasing. Okay, this is a hypothetical pictures of impact of El Nino past and present. You can see in the past, well, El Nino is okay. There was some rain. Sorry, this is El Nino in the past, and now it looks like sparking everything. And it's true, because this year the impact was quite visible, quite severe. But this is not even a strong El Nino year. This is currently it is a very weak. But some people even hesitate to say weak. Some people even argue this is cancer neutral. Even then, we have a tremendous impact. Okay. Now, I would like to summarize these sections. El Nino is a major warming of the equatorial waters in the Pacific Ocean. Assisting the tropical Pacific increases by 5 to 1.5 degrees Celsius in the North 3.9 area. And weekend trade winds. La Nina just opposite. As compared to 1950 to 1980, the number of El Nino La Nina years have considerably increased in 1980 to 2015. Scientists argue that this, at least in part, is a result of climate change or instability. Huge global impacts, physical consequences. Impacts are visible in sea level, rainfall, and tropical cyclone activities. Social consequences. Drought is widely believed to relate to conflicts. Even conflicts in the tropics doubles during El Nino year related to La Nina year. 21% of conflicts are contributed by El Nino, La Nina. Okay, now impacts. This is the study area. USAPI Pacific Island is located in the North Pacific. Almost all of our islands are in the North Pacific, except one, Pago, which is American summer in South Pacific. These areas are most vulnerable to climate variability and change. These economic plans are dependent on climate-sensitive sectors. Water resources are stressed, and so has significant impact on the overall. You see, this is the picture in Manoa. Water is gold in USAPI reasons. In 2000. In 2000, Pacific Island Managers meeting in 2000, the phrase water is called hard in 2000, Pacific Islands Managers meeting. Drought is a great concern there. As I mentioned before, limited water storage supply, limited groundwater, little or no surface water. So they are dependent on rainfall. So rainfall catchment. So rainfall is the only source of water they save for drinking, everything. And you see, this is, every house has a tank like this. They save this water. The right panel is El Nino here. This is the billboard that we, Pacific Cancer Application Centers, used in 1997-8 to disseminate this message that we are in a state of El Nino. We are in a state of dry or drought. So save water, ration water, and be ready for it. And this helped a lot the island communities to manage that disaster in 1997-8. We're doing the same thing again in this year. So this is an impact. This is a picture of 1997-8 in Metro. Low rainfall, low sea level, water rationing in Metro. People had to lie like this, and they got 1 bottle of water once a week. 1 can of water once a week for drinking. And this water was transferred from California, shipped from California to Metro. And they are given 1 can of water once a week. So, I mean, it's very difficult for others to think about it, how serious and how dangerous the situation is. This is what happened in 1997-8. And this rationing and water, these are all based on the information that we have provided, Pacific ENSO application self-provided in 1997. We did this, we made this rainfall focus, we advised them that you are going to have a serious drought this year, we don't have enough water, now do something to get some water from somewhere. And they talked to the FEMA. FEMA provided them water, shipped water from mainland to metro. So that's how climate information, that's how climate prediction, that's how it supports the water management system. The right picture is a picture of La Nina, which means it is higher than normal weight. In 2008, 7, 8, this is only major urban thoroughfare in Chuk. This was inundated like this in 2008. So that's only what they had. Down the road, it was underwater during 2007 and 8. Heavy rainfall, damage of roads and infrastructure, agriculture and other things. And this kind of La Nina actually changes surface and groundwater quality because it has salinations problem. Okay, those were US affiliated Pacific Islands. As I said, there was something about Bangladesh too. I will touch very briefly. This is the hotspots of climate hazards, Bangladesh. You might have heard about it. You see, this is the current situation. In 2050, it will be dry like this. And currently it is everywhere, it's like that. There are many rivers when I swam when I was a kid, and those rivers are no longer there. It's almost, I remember 10 years ago I saw paddy field, now I saw the tea stalk, so there's even no paddy field there. River gone, paddy field transfer, and now it's just like road. So this is the whole picture nowadays. And this is a picture of 1998 flood. Maybe you have heard about it. This picture I show everybody. And this is a very high diplomatic area in Dhaka. In 1998, Bangladesh was underwater for 3 months. Just 3 months. I was there physically present there. And this area was even in the most expensive area. It is one of the expensive areas in the world nowadays. And this area was also underwater for about 2 months. And I show this, American this was very close to this place. And this is another picture. Anyway, so what is this? This is a serious water management challenging issue in Bangladesh. Basin-wide rainfall runoff is the primary cause of flooding. Approximately 20% of the country is flooded annually. Floods of 1954, 74, 87, 80 inundated about 50% of the country. 1998 flood inundated 90%. In a major flood, non-crops damage are higher than crop damages. Water resources are already stressed. Economic plans are again dependent on climate sensitive sector. Okay, so these are the impacts. So if I summarize these impacts, now it looks like both the US affiliated Pacific Islands and Bangladesh are affected by ENSO. El Nino to dry and La Nina to wet climate. Water resources sectors are heavily affected by ENSO. It is a great challenge as well as it's a great opportunity for both the Pacific Islands and Bangladesh to adapt with the ENSO effects. Excuse me, how much time I have?
You have around 20 minutes left.
Okay. Okay. So this is my third section.
That will be including the question and answer session. So.
Oh, okay. I'll finish it. This is the third section, and this section I'm going to show that so basis load focus for water resources management. How can we produce? How can we utilize ENSO to generate the new information for water resources management? That's the thing. And in 1990, when PEAC was developed, we had came into being in 1994. In 1990, the government of the USAPI Pacific Island regions expressed their concern about climate variability. And what they wanted customized climate services, which is tailored, understandable technical information products for climate-sensitive sectors. The problem was that at that time, or even today, the spatial resolution of large-scale climate models are too poor to apply to these islands directly. So we had great models, we had great papers, but that didn't really serve the purpose of the islands. Because islands are very small. One island is Majuro, which is only 80 square miles. So those global models, the grid point 1 degree, 1 degree, doesn't really do anything for those models. So you have fancy models, fancy informations, but it doesn't really serve your purpose. So they raised that issue at that time and said we need something that really touched the base of our climate variability and change. It was very challenging to us for PEAC, how to do and what to do. So what we did at that time, used the output of those models, and tried to correlate the local climates, local rainfall, local sea level, local tropical cycle, and see if there is any correlations. Once we found some correlation, that was very encouraging at that stage to start something new, a downscaling, a statistical model. Okay, so I define it as at PEAC, the output of the large-scale model data are used to develop statistical model for sea level and rainfall focus on physical time scale. So we use the output of those models and we just try to correlate and see the relationship between our local climate data, island-wise climate data. Because every island was, and you will find that there is even the variability within the island. The islands are very close, near to each other, but there's something different. So you have to try with all the individual islands. What we did, this is a picture of sea surface temperature. At first point, what I did, we started this way. We took the total rainfall data and sea level data and isolated the highest 5 rainfall, highest 5 years of rainfall, and lowest 5 years of rainfall. Then made a composite like this. With the sea surface temperature data. So wanted to see that those highest 5 years has anything to do with the Nino 3-point area. But as we say that El Nino means dry, La Nina means wet. So the lowest 5 years, which means the dry year, and during that 5 years, the sea surface temperature in the Nino 3-point area, according to hypothesis, should be La Nina, El Nina-ish type. And that's the composite here you see. This is the SST average of lowest sea level years. So let's put sea level right now. Lowest sea level years, 1967, 7, this the 5 lowest sea level years. And this is the sea surface temperature composite. And you see all El Nino season. Same, the highest sea level years like this, all La Nina season. So that's a very basic idea or very basic hypothesis that we had. The climate variability in the US affiliated Pacific Islands are correlated to the sea surface temperature in the Nino 3.4 area. At least the extremes, if not linearly variable. The next step was to see whether there is a linear relationship between the sea surface temperature data and the rainfall data or sea level data. This is the linear correlation between sea surface temperature data and the rainfall data. We found there is, at least for a season, for 3 months in advance, there is a very good correlations. This composite all indicates La Nina time. This is all La Nina time. So the sea level, the correlation between the sea level and the sea surface temperature was very promising. I won't say that it is optimistic, but was very promising. I mean, we can generate some forecasting scheme from this information. So that was the starting point. And well, I believe the empirical orthogonal functions, that's the term familiar you all? Okay, if not, that this is the kind of mathematics that we use as is we call empirical EOF1 as principal component analysis. That's separating the different types of correlated variables to a smaller number of uncorrelated variables. Anyway, let's put it in this way. This is one of the state of statistical downscaling. So we use this, then we use the statistical method to between two sets of variables. One is the sea surface temperature, and the one is the local rainfall or sea level. So based on this, we need to see a canonical correlation analysis. And I believe this is canonical correlation analysis is, you are all familiar with this. And this is a tool that determines the relationship between two sets of variables. So we found there's a quite promising skill. Promising skill is 0.7 and above in most of the cases, except this year. And so this skill gave us a confidence that a forecasting scheme based on sea surface temperature is doable, and we then prepared that focus, provided it to the, sent it to the field, and they used that. Okay. Well, as I said, when I'm talking about the sea surface temperatures, but as we started to supply a sea surface temperature based focus, the demand for longer time scale focus was raised. People wanted to have more. They wanted to have longer time scale focus. So the only way we tried to do that is utilizing wind in addition to sea surface temperatures. And that's how we improved the focus. And with the sea surface temperature, the focus is doing great, much higher than before. Okay. This was the sea level. The rainfall is that in the Pacific Islands, we use several model. ACMF, NWF, UKMO, NASA, APCC, and NSET, and IRI. 6 dynamic models and 2 statistical models. And then we make an ensemble. And the approach is same, just taking the sea surface temperature and local climate data and downscaling. So, as I mentioned from the very beginning of this talk, that we are providing information on seasonal time scale. This is something different from the weather focus. In seasonal time scales or seasonal focus, it is not that simple that you have some products, send it to the people and ask them to use it. No, it doesn't really work that way. Seasonal time scales is that mean there is a probability factor, uncertainty factor. So when you supply in this kind of information, you have to make people aware of what does this information tell to them. So in a sense, what happens, we have to have the users on the same table as if we are all working together. And that's the unique approach that we are using now. We are having our users in the field. They are part of the whole system. I mean, just so-called the eyeball-to-eyeball contact. Once we prepare some focus, we put it on the table, ask them for their comments. They come with their ideas. They contribute with some new things if they have. At least they know what our focus means and how to interpret that focus, because there's an uncertainty factor. And this is how I think the way PEAC is doing a great job, and it's very successful because of this mission. And every month, through a teleconference, we call them, and they are part of the system. So I call it a 5-stage operational model to provide ENSO-based climate focus and advanced warnings to the USAPI users. One of the reasons that why ENSO-based information are not injected to many other countries because they don't do that. They just make ENSO information and try to tell them, oh, okay, here has tons of information, go and use it. They don't do the way we do. Because you have to make people aware what this information tells. Why this information is different from other information. What does this climate information mean? The time scale. And what does this uncertainty mean? And where is the uncertainty? And that's, I think, a great achievement or success from our perspective. So what we do, we step one, the preparation of the focus, interpretation and message formulation, that's what we do. Warning preparation and disseminations, response and feedback, and review and analysis. These are not one by one, I'm going to show. These are actually like this. A flowchart like this, it's an interactive process, have feedback. Every stage we get feedback from different corners, starting from. We are just in a center that has a both forward linkage and a backward linkage. We maintain a very close relations with the scientific community as well as the users community. We try to communicate with the scientific community if there was any findings from the ground. So this is how, as an interactive process and feedback. I don't like to explain more about it because maybe time is not enough. So that's how we work. So in our monthly conference, we put all this information on the table. People are also react. I would rather say the word they react. And after reactions, we made it consensus focused. So everyone is part of this focus. They like to have this information, we use it. And that's how we do it. This is maybe funny, but we had our 100th conference call in March 7, 2013. Okay. So, summary. The ENSO-based seasonal climate outlook has significantly enhanced the local government's capacity to address water-related disasters. The output of large-scale model data can be used to develop statistical focusing scheme on seasonal time scale. 5 is research and operational model focused in interpretation, message formulations, warning preparation and disseminations, response and feedback. Review and analysis is an efficient way to generate consensus seasonal climate outlook rather than interactive dialogue with users is essential and should be continuous. Eyeball-to-eyeball communication. I think that was very great for us. Okay, just 2-3 slides about Bangladesh. What happens in Bangladesh, you see that the major years, this is a picture that shows 1995, dry years. I'm sorry, 1995. These are the dry years, and these are the wet years. So what happens, all El Nino years are dry, all La Nina years are wet. And what we do, you see, this is the flood affected area, deviations. So it is so dry with strong El Nino years, but it's very wet in the La Nina years. The problem is with this. So again, the SY extreme has a very close relationship with the flooding. With the flooding, if it's SY is positive, SY is negative, extreme, that is dry. Is positive, is wet. The same way, like the USAPI Pacific Island, we did the same analysis, taking the 5 highest, 5 lowest. Actually, I did it before I came to Hawaii. So what I did in the USAPI, based on my knowledge from here, now let's say no wet. In case of Bangladesh, the focus was made on flooding. This is the flood affected area. The same correlation map, the way we did. So it's the same approach. Okay, so what does it tell us? That climate variability in the US, affiliated Pacific Islands, and Bangladesh are sensitive to ENSO. It's correlated. ENSO-based regional focus is successful for water resources management by USAPI region. Bangladesh can also benefit from it. Well, they are trying, they are. As an adaptation strategy, ENSO-based climate information products are helpful for longer time scale water resources management. So that's it for now.
So we can have questions.
Yes.
How did you modify your protocols this year after there was kind of a large El Nino prediction that didn't materialize? Because at the beginning of the season, there was a huge warm pool that everybody thought was going to lead to a huge El Nino, and it turned to kind of fizzled. So how did you have to modify your normal operating procedures to deal with that? Because otherwise it could have been a big scare for no reason.
Yeah, I think there's, so for example, what can be done for us, we do in the Pacific Islands, once we have the knowledge that this year there's a possibility of El Nino. This gives us one kind of confirmed signal that this is not going to be a La Nina. That's a huge information for us, that we are moving in one directions or no directions. Either it's going to be a neutral or El Nino, but in any case, no La Nina. The two are two opposite things. So once, maybe, I know, if it is an El Nino, it's a weak El Nino, we need one type of preparations, moderate, a different type of preparations, the strong is another complete different things. Yes, that part is still challenging. We are facing difficulty. But again, this is giving us a sort of clear idea that we are in that state of either ENSO neutral or El Nino, at least not La Nina. So we need to be ready for dry or drought, not for flooding. I mean, that's the way we go.
So in your case, do you go prepare for the worst scenario
Yes.
of the
Yeah.
Manoa?
Yes, as I say, depending which month of the year and how the Nino 3.4 area behaving. But first is that either we are in the state of El Nino or La Nina. But usually it didn't really happen like that. We are all thinking El Nino, and all of a sudden a La Nina. That didn't really happen. We think El Nino, it is either El Nino or neutral, but never turn back like that. So if we see that, yes, so for example, this year, I think we are preparing for at least a moderate scale El Nino. And although the definitions sometimes is not very clear for us, sometimes impact is there, but it doesn't really fall under the definition of El Nino. So as I said, this is not no straight way. You have to, it's very challenging, and you have to be very, very aware of it and see how to synthesize all information together. But currently, we don't not necessarily always prepare for the extremes. If it is a weak El Nino, why should we go for extremes? But if it's an extremes, we definitely go for that. But we know at least 2 to 3 months before we know that's going to be the strength of the event. So currently we know it's going to be a weak to moderate type of strength. Usually weak to moderate or moderate to strong. That's the scale always in our mind. And our experience there, we are quite skillful in that sense.
Of course, I'm interested in water resources. And in general, basically, we are interested in local scale, like the Pacific Highlands and Pacific Island. And like some American Samoa, for example, they don't have enough climate data. They hardly have any weather stations around the island. So what is the solution to that? Local scale is possible to make forecasts based on larger scale. How do we deal with that?
I think those islands are so isolated. Every island, it's better to try with the local island data. And American Samoa, I think their data is well. We have many data for American Samoa too.
That's good to hear.
Many. We work for American Samoa. We have sea level data, we have rainfall data, and it's about 70, 80 years there. We have that. So, and what can you do? The American Samoa, next one is Western Samoa. Western Samoa. So the climate for both the Samoa is very similar, but as per mandate, we work for the American Samoa because it's USAPI. But the nature of the variability in the Western Samoa is also similar. So if you're interested for American Samoa, fine, PEAC maybe, even tropical cycle. I think we have a lot for American Samoa. And we definitely can guide if there is any information.
But still my question can be also, like say, some areas when you don't have enough data, can you still be maximum?
I think so, depending upon the statistical correlation with the output of the global model. If model of certain section, if we have correlation with that sections to local climate data, then there is a relationship. Then we can say, well, there is a correlation. So we definitely can predict, make some focus for that when there is no data. But in that case, we at least we need to have a GCN for that area. That should be the starting point. Otherwise, it might be difficult. But I think GCM is everywhere now done. We have hundreds of GCM available. So, yeah, it's doable.
Any more questions? So, Dr. Chowdhury is with us at Manoa, so if you have additional questions and queries, you can always contact him at the
Yes, we just HIG 350 next to this building.
And then climate, variability, water resources, these are all exciting things. And then please contact him if you need any further assistance. And I would like to thank you for presenting this research and these findings, and thank you all for coming today. Thank you.